Hello, another quick video for our statistics class in this virus ridden times. So in this quick video, we're going to talk about countif, a quick way to count something here. We're going to mention encoding, and we're also going to practice making a special chart called frequency polygon. Let's say you have this list over here, that's a list of students and their grades and where the students are from. And say you want to count the distribution of students by location. In the previous video, we were counting sort of by hand, but that can be quite time consuming and also prone to mistakes. In this video, let's use this countif formula. Just hit equals over here, countif, open the brackets, show us the range, and count everybody who are from Bristol. Bam! And it doesn't work, because before I can use countif formula, I gotta encode these locations. Instead of having them as words, I want to have them as numbers. So this is the way I'm going to encode locations. Let's say London will be encoded into 1, Bristol encoded into number 2, and so on. To do that, I want to add another column for my encoded locations so that I don't lose the original column. Let's add a column, encoded location, Control-Shift down, select all of that, and insert. Now I select this column, Control-F, and replace London with the number 1. Replace all, 14 replacements done. I move on to Bristol, to be replaced with number 2, replace all, and so on. Once I'm done with encoding all of these locations, I can count number of students from those locations pretty easily. Equals countif, give it a range, and click here so that I have a formula which I can just copy instead of typing this every time for every location. For the range, I want to hit F4 so that the range location doesn't shift as I copy the formula. Then I'm just ready to copy it. And what I have here is a frequency table. Next, let's say I want to make a chart, a frequency polygon chart for the grades that the students have. In that case, I have to first perform a few actions. First, I need to break down all of this list into several classes because grades vary a lot. I'm going to break them down into classes. For example, one class might contain grades from 50 to 60, another class 60 to 70, and so on. To count the number of classes that is recommended, we're going to use our formula where 2 into the power of that number of classes should be no less than the number of observations. In this case, we have 82 observations. So 2 into the power of this number on the left will give me the number that I want to compare with the number of observations. As you see, 6 classes is not enough. Whereas if I have 7 classes, the formula gives me a number greater than my number of observations, which is 82. So I'm going to have 7 classes. Next, I want to find out what's the class interval. For that, I gotta look at the difference between minimum and maximum value of the grades and divide by the number of classes. Let's find what are the minimum and maximum. Equals min, open the brackets, and give it that column. 52 is the smallest grade, and equals max, open the brackets, that grade column, 91 is the highest grade. So the interval is, of course, maximum minus minimum divided by number of classes, and I want to round that up to 6. Now looking at the range of grades, our actual range is 37. That's the difference between minimum and maximum values. And the range created by number of classes and the class interval is greater than that. 7 as the number of classes multiplied by 6 as the class range is going to give us a range of 42. Somehow I want to fit the actual range more or less in the middle of the formula range. There's a difference of 5 grades, so I want to have 2 or 3 grades on either side of the actual range. So at the bottom class, I will start 2 or 3 points below the minimum number. So 51 sounds fine for me, and the class interval is 6. So 51 to 56 is the range of the first class, which includes 6 grades. 57 to 62 is the range of the second class, and so on for all the 7 classes. So that gives me the classes with these ranges as you see. Of course, you could have chosen other ranges. For example, you really could have chosen round numbers, one class including all the grades from 50 to 60, another class including all the grades from 60 to 70, and so on, all the way up to, say, 100 or so. Or you could have the last highest class only go from 80 to 91, instead of having a separate class for grades between 90 and 100. But for our tests, I want you guys to make note of the way we calculate the suggested number of classes and class interval. That's why I'm going to stick with the suggested numbers. Next, in case of frequency polygon, I want to calculate midpoint for the class ranges. That's going to be the lower number of the range plus the higher number of the range, all of that divided by 2. After that, we're going to calculate the frequency of how many students have those grades within each of the classes. For that, I just click anywhere within this data table and sort it by the grade. Go to data, sort by grades, and I'm going to count the number of students with the grades within 51 to 56. I'm going to do it by hand for now. That's only 3 students. Next, 57 to 62. That's 11 students. Next, 63 to 68. That's 19 students. Next, 69 to 74. 6 students. 75 to 80. 15 students. 81 to 86. 12 students. And the last class having 16 students. And lastly, to make the actual frequency polygon, I select these numbers over here, go to Insert, Align. That's our frequency polygon. Let's put it in a separate chart so I can see it a little bit clearer. But what do I have here at the bottom? What I want to have here are the midpoints. So right-click anywhere on the chart, select Data, and you're going to change the horizontal axis values. Go to the sheet where you were, select these midpoints, and OK. OK again, that gives you the midpoints. Give this chart a proper name, and you're done. The highest point on the frequency polygon over here corresponds to the midpoint of the largest class. So the typical grade within our student list is somewhere around 65.5.